Hello, it's Dr. Alton Simpson, and I'm honored to be here. Today, we're going to instruct in the design and demonstrate a simple relational database. Here's a little bit of information about me. Today, we're going to take a practical look at how to design a simple relational database and explore how SQL queries, entity integrity, distributed databases, web technologies, and security considerations all fit together in the bigger picture of data management. You do not need to be a database wizard to understand this. Think of it as learning the language that helps computers organize and share information in a structured way. What is a relational database? Relational database organizes data into tables, like spreadsheets with rows and columns. Each table stores data about one type of thing. For example, a student's table, a courses table, and an enrollments table. The relationships between these tables, established through primary keys and foreign keys, let us connect information efficiently. For example, each student has a student ID primary key. The enrollments table references that student ID as a foreign key. This structure reduces data duplication, improves consistency. That's the beauty of the relational model. Let's design a small database for a college course management system. We'll start with three tables: students, student ID primary key, name, email, courses, course ID primary key, title, instructor, enrollments. Enrollment ID primary key, student ID foreign key, students, course ID foreign key, courses. This design shows one-to-many relationships. One student can enroll in many courses, and one course can have many students. You can easily diagram this with an entity relationship diagram showing those links. Once the structure is ready, we can use SQL structured query language to manage and retrieve data. Here are some common queries you might demonstrate: creating tables, students, inserting data, student values, select student's name, course's title from enrollments, student ID. This last one shows the power of relational databases, combining data from multiple tables to create meaningful insights. Entity integrity. Why entity integrity matters. Entity integrity means that each table must have a unique identifier, the primary key, and it cannot be null. This ensures that every record can be uniquely identified. If we accidentally had two students with the same ID, the system wouldn't know who's who. Similarly, referential integrity ensures that relationships between tables remain consistent. For example, you cannot enroll a student who doesn't exist in the student table. Together, these rules keep the data accurate and reliable. Every table must have a unique primary key. In today's world, data doesn't live in one place. Multiple servers, sometimes even different countries. This improves speed, reliability, scalability, but it introduces challenges like consistency. When you interact with web applications, say logging into your student portal, you're indirectly using a database. The front-end web page sends a request to a back-end system, which executes SQL queries behind the scenes, retrieves data, and displays it in your browser. So web technologies and databases are deeply interconnected. Finally, let's talk about distributed databases and security. Some key practices include authentication, authorization. Only approved users can access modified data. Encryption protects data during transmission and storage. SQL injection prevention. Always validate and sanitize user inputs. Backups and access logs help detect and recover from breaches. Good database design always includes security. It's part of the foundation, not an afterthought. And in conclusion, some of the key takeaways to wrap up. A relational database isn't just a collection of tables. It's a carefully designed system that ensures data integrity, efficiency, and security. With a bit of SQL and sound design principles, you can build systems that power everything, from a college course portal to massive global applications. Thank you. And remember, in data, structure is power.